Here you have an equation in which you have denominators. However, you also have parentheses, and as a general rule for solving any math problem, it's always good to follow the rules of PEMDAS. So I will begin here by opening parentheses and simplifying the numerators as much as possible. So that means distribute this 3 to both terms in the first set of parentheses, and then distribute this minus to both terms in the second set of parentheses. So as we do that, we obtain 3n minus 6 plus 5 all over 4 equals 11. And then please remember that the effect of a minus in front of parentheses is that it changes the signs of all the terms inside the parentheses. So since the 7 in this set of parentheses is positive, it will change to minus 7. And since the n in this set of parentheses is negative, it will change, the negative sign in the front will change this to positive n. And that's all over 6. So at this point, we combine like terms. 3n is by itself. There's nothing that it can be combined with. So minus 6 plus 5 becomes negative 1 all over 4 equals, and then we have 11 minus 7 is 4 plus n all over 6. At this point, you have a choice. You can cross multiply, and that will certainly work, or the better choice is always to apply the general method for solving equations that have denominators, and that's find the least common denominator and multiply all terms of the equation by that least common denominator. So in this case, the least common denominator between 4 and 6 is 12. And so what I will do is multiply this term by 12 and also multiply the right-hand side term by 12. And as you do that, please don't distribute the 12 to the numerators. You could certainly do that, it's not wrong, but you end up working with larger numbers and you unnecessarily complicate things. Instead, reduce, right? So here, reduce the 4 and the 12. 12 becomes a 3. Reduce the 6 and the 12, and here the 12 becomes a 2. At this point, you may want to add parentheses to remind yourselves that whatever numbers you obtained need to be distributed to all the terms on the side of the equation where that number was obtained. So in this case, we obtain 9n minus 3 equals 8 plus 2n. And pause here to reflect on the fact that this is the effect of multiplying by the least common denominators. As you can see here, we had an equation with denominators which looked fairly complicated. But as soon as you multiplied by the least common denominator, you obtain a fairly simple linear equation. No more denominators here. So at this point, in order to solve, combine the variables to one side. So I will subtract 2n from the right-hand side. And as we do in an equation, do exactly the same thing to the other side. They will cancel from here, and we will obtain 7n minus 3 equals 8. And now group the constants to the right-hand side. So therefore, since this is minus 3, do the inverse operation, so plus 3 on both sides, right, which cancels the 3 from here, and we obtain 7n equals 11. And at this point, to solve for n, to isolate the n, right, since 7n means 7 times n, right, I will again do the inverse, perform the inverse operation, and divide both sides by 7. The 7s will cancel on the left-hand side, and we obtain the final solution, n is equal to 11 over 7. As a final note here, if you're not sure how to obtain least common denominators, it may be something you may want to look into and ensure that you're able to do this quickly and efficiently for solving this type of problem.